In the Bode plot, basically we have to first we have to convert the transfer function in the time constant form 1 plus st or 1 by 1 plus s by omega c, ठीक है, in this form only. So if the transfer function is given like this, k by s power r, it means something s power 2, s power 3, s power 4, something like this, then the slope will become minus 20 into r. It means why? Because it is a pole, okay, so negative sign. And same it is a, if it becomes, if it is zeros, then plus 20 r, okay. If let's say s by s square, so it means minus 20 dB per decade, and if s power 2, then it is plus 40 dB, minus 40 dB per decade, and it is plus 40 dB per decade, okay. Same says only one pole are there, so minus 20 dB per decade, one zeros are there, plus 20 dB per decade. If two poles are there, minus 40 dB per decade, and if two zeros are there, then plus 40 dB per decade. And if the second order transfer function is given in a pole constant form, okay, in a second order transfer function, then it becomes like this. It means mr resonance peak are there, okay. So you have to check this formula, you have to check this formula. This formula you have to check. mr, it means resonance equal to a by 2 zeta under root of 1 minus zeta square, okay. So basically we have to keep in mind, it means 20 dB per decade equal to 6 dB per 6 dB per octave. It means 10 times change, so it varies 20 dB. 2 times change, it means 2 times change, then it varies 6 dB per decade, okay. And next we have to keep this in mind, okay. It means magnitude in dB equal to minus plus 20 r log of omega to the base 10 plus 20 log of k to the base 10. If initial slope is zeros or pole, if pole, then minus will be taken, if zeros, then plus will be taken, okay. We will see in the question how we can use this formula, okay. So let's check this question, okay. So already it is given in the time constant form 1 plus st, 1 plus st, 1 plus st something, okay. So it is already given in the time constant form. So if you will find the time constant, then 0.1 and 0.2 and 0.5. But whenever we have to draw the Bode plot, okay, so we have to we need corner frequency, okay. So corner frequency is 1 by time period, 1 by time constant, okay. So 1 by 0.1, so it will become 10, okay. 1 by 0.2, so it will become 5. 1 by 0.5, so it will become 2, okay. So we have to arrange in a increasing order, okay. So just draw here. It means let's say here 2, let's say here 5, let's say here 10, okay. So just take whether any zeros are pole at the origin or not, okay. So here one pole is at origin, so if one pole at is origin, if one pole is at origin, then minus 20 dB per decade, okay. So initial slope is minus 20 dB per decade, so initial slope is, let's say, minus 20 dB per decade, okay, minus 20 dB per decade. Now at omega equal to 2, at omega equal to 1 0 is added, okay, 1 0 is added at omega equal to 2, so minus 20 dB per decade, and 1 0 contributes the plus 20 dB per decade, so minus 20 and plus 20 will become 0, okay. So it becomes 0, minus 20 dB initial slope is there, and it is plus 20 dB, so minus 20 plus 20 is 0, okay. So it becomes here. So at omega equal to 5, one pole is there, okay. So one pole contributes minus 20 dB, so 0 and plus minus 20 dB, so it becomes minus 20 dB per decade. So minus 20 dB per decade, here dB per decade, so we don't write here again and again. So at omega equal to 10, again one pole is there, so it contributes minus 20 dB, already minus 20 plus of minus 20, so minus 40, so it becomes minus 40. So in this way we will draw the Bode plot, okay. So if you will draw the phase plot, so initial slope is minus 90, initial one pole is there, okay, at origin, so minus 90 degree, let's say minus 90, minus 90 degree. Okay, so again again one 0 is added, so it becomes 0. Okay, so it becomes 0, and again one pole is there, so it becomes 90, and again one pole is there, so it becomes minus 9 minus 180. Okay, and up so it goes at 2 and 5, and it is 10. Okay, in this way we will draw the Bode plot. Now move to the next question. Okay, so question is given 10 power 3 into s plus 20 divided by s square plus 210s plus 2000. Okay, so first we have to find in the time constant form or 1 plus s by omega c form. So already we find it 1 plus st form. So here we find omega c is 10, omega c is 200, omega c is 20. So just plot omega is 10 and some 20 and 200. Okay, so is there any pole and zeros at origin? No, so it will be a constant line. Okay, initial it will be a constant line. At omega equal to 10, it is a pole or zeros, so it is a pole, so it contributes the minus 20 dB per decade. So minus 20 dB per decade, minus 20 dB per decade. Okay, so at omega equal to 20, no, just see, at omega equal to 20, 1 0 is contributes. Okay, so 1 0 it means plus 20 dB, minus 20 plus 20, it becomes 0 dB per decade. Okay, at omega equal to 200, one pole is there. Okay, so one pole contributes minus 20 dB per decade, so it is minus 20 dB per decade. So it goes like, okay. So in this way we will draw the magnitude plot, and same we can draw the phase plot. So phase follows: initial no zeros and no poles are present, so initial slope will be 0. Okay, at omega equal to 10, one pole is there, so one pole contributes minus 90 dB, minus 90 dB. Okay, at omega equal to 20, 1 0 is contributed, so 1 0 contributes the plus 20 dB. Okay, so minus 90 and plus 20, it means, sorry, minus 90 and plus 90, so it becomes 0, it becomes 0. Okay, at omega equal to 200, one pole is contributed. Okay, so one pole contributes plus 90 dB, sorry, one pole contributes minus 90 dB, so it becomes like this. So it is the phase plot. So another type of question will can be asked from here. So phase margin can be asked. Okay, so phase margin, we have to first, in phase margin we have to find omega gc, gain crossover frequency. It means gain crossover frequency, it means angle should be angle of g omega equal to minus 180 degree. Okay, so minus 180 degree should be and for simply omega gc it means gain crossover frequency. So magnitude in dB should be 0. Okay, so magnitude in dB magnitude in dB should be 0. Okay, so you can check anywhere. Okay, so let's say here, if we will find the here magnitude. Okay, so how much magnitude will be there? So magnitude is 20 log of k. Why? Because there is no pole and zeros here. So if no pole and zeros here, so it will become 0, or at omega equal to 1 it will become 0. So only magnitude is equal to 20 log of k. So magnitude equal to 20 log of k. Okay, so magnitude equal to 20 log of k. So k is kitna? 10. So 20 log of 10, so it becomes something 20. Okay, so it becomes 20. So just check here, it means how many times? 2 times. It means octave means 2 times change means 6 dB per decade. Okay, so 6 dB per decade, so just decrease 6 dB, so it becomes 40 dB, it means 20 dB. So 0 dB somewhere lies here. Okay, 0 dB somewhere lies here, so we have to find from here. So we have to find slope here. Okay, slope in this way, how slope is finding. So slope in this way we have to find. Okay, y2 minus y1 divided by log of omega c minus log of 200 divided by minus 20, because slope is minus 20. Just see here. Okay, just 1 minute. it's fine. So here somewhere 0 dB per decade, okay, somewhere 0 dB per decade. So y2, it means 0 dB minus y1 divided by log omega c minus log omega 100 equal to slope is minus 20 dB. Same thing is written here, okay. So by calculating we can find omega gc, and omega gc, if we will put in this formula, phase margin equal to 180 plus angle, so we will find the omega gc, then we can find the phase margin, okay. Now let's move the another question. So if question is given like 100 divided by s plus 10 divided by s plus something this way, so first we have to find in the time constant form. So in time constant form, just remove here 10, just common, take common 100, take common here 1000 and take common 10,000, so it becomes like this, okay. So it means we have plotted here, we have written here omega is 10 and 100 and another 1000 and another 10,000, okay. So initial slope is like 0 dB, no pole and zeros are present, so initial slope is 0 dB. Another one pole is added at omega equal to 10, so it means it takes 20 dB, okay. So one pole is added, so it takes, or minus 20, yeah, minus 20 and again plus minus 20, so it becomes minus 40, so somewhere is minus 40 dB. And again one pole is added, so minus 120 degree, it means minus 160 degree. And again one pole is added at omega equal to 1000, okay. The graph is like just in this in this way, okay, minus 60 dB, and omega equal to, let's say this will be minus 80 dB per decade, okay. So in this way we can find the Bode plot in this way. Now move to the next question. Here already given the Bode plot, okay, so we have to find the transfer function. So transfer function is k divided by 1 plus, so here just look here, how many times, 100 times, it means 20 dB per decade. So here 2 decade are there, okay, 10 square, it means 2 decade. So 2 decade contributes 120 degree, it means 60 dB per decade, 60 dB per decade, okay. So 60 dB per decade, it means we can say plus 60 dB per decade. So if plus 60 dB per decade, it means definitely here 3 zeros are present, okay. So 3 zeros are present, and just check here, here how many dBs are gap, how many dBs, 20 dBs, and here 1 decade. So 20 dB per decade means it means 20 dB per decade plus 20 dB per decade, it means 1 zeros are added, okay. But here plus 20 dB per decade, okay, here 20 dB per decade, and here it was coming plus 60 dB per decade, plus 60 dB per decade. So plus 60 becomes plus 20, it means definitely here 2 poles must be there, okay. So plus 60 and minus 40, minus 20 into 2, okay. So in this way we can say here 2 poles are there, okay. So finally slope is becomes 0, so definitely here one pole are there, why? Because here 20 dB per decade and one pole, it means minus 20 dB per decade, so plus 20 minus 20 becomes 0. In this way we can say here 3 zeros are present, here 2 zeros are present, here 1 poles are present, okay, 2 pole and 1 pole are present. So we can write 1 divided by 1 plus 0.1, here 3 zeros, so 3 zeros divided by, here 2 pole are present, 1 plus s by 10 whole square, here 1 pole are present, 1 plus s by 100, okay. In this way we can write. Now main thing is that we have to find k. So just check what is the initial slope. So initial slope is 0, so directly apply magnitude equal to 20 log of k, and magnitude is given 20 dB, so 20 equal to 20 log of k to the base 10. So 20 cancel, it means log of 10 to the base k, so k equal to 10 power 1, which is becomes 10. So here 10 comes, okay. So we can find the transfer function 10 into 1 plus s by 0.1 whole square. Just put here 10. Okay, so it will become the transfer function. Now move to the next question. Okay. So in this question, main challenge is that we have to find transfer function. Okay, so first we have to find omega 1, omega 2, then we can proceed this question. So just check, initial slope is given minus 20 dB, and again 1 and again 1 zeros are added, then it becomes 0, and here 1 zeros are added, here 1 pole are added, so 0 becomes minus 20. Okay, so 1 pole are added, it means 1 zero contributes plus 20 dB and 1 pole contributes minus 20 dB. Okay. So let's how we will calculate these thing. So magnitude, so we can find k. Okay, k. So here initial slope is something, it means initial slope is given, not 0, so we have to use this formula. Okay, minus plus 20 r. So just check, initial slope is initially pole are there or zeros are there. So here pole are there. Okay, minus 20 dB, it means pole are there, so directly use am equal to minus 20 dB log of omega plus 20 log of k. So magnitude is given at omega equal to 0.132 dB. 32 dB minus 20 log of 0.1 plus 20 log of k. By solving these, we can get here k equal to 4. Okay, we can get from here k equal to 4. So initial slope is minus 20 dB, so 20 into r, minus 20 into r is 1. Okay, so minus 20 dB simply. So we found the k. Okay, so just use here slope formula. Okay, slope formula, it means y2 minus y1 divided by, just see here, we are moving in this way. Okay, so it becomes y2, it becomes y1, so omega to omega 1. Okay, so in this way here magnitude is 6 and 32 dB are here, minus 20 dB per decade. So slope is minus 20 dB per decade. Okay, so y2 minus y1, it means 6 minus 32 divided by log of, at omega at magnitude 6, what is frequency is omega 1 minus at 32 पे log of 0.1. Okay, by solving this we can get, so just we can write here omega equal to minus what comes minus 26. Okay, minus 26 divided by log of 10 omega 1. So just solve here, we will get the omega 1 equal to 2. Okay, so same way we have to find the here slope formula, it means omega 2 minus omega 1. Okay, so omega 2 minus omega 1, it means slope is minus 20 dB. Okay, so here magnitude is 0, here magnitude is 0, it is given omega value, it means omega value it is given, so magnitude is 0 here, 0 minus at omega equal to 6 पे, just observe this. Okay, minus 6 divided by log of omega 2, it means log of 10 minus log of here what is the log of omega 2. By solving this we will get the omega 2 equal to 5. So just put here, it means just put k into, so initial matlab initial slope are there. Okay, initial slope is given, it means one pole are at origin. Okay, one pole are at origin, initial slope is minus 20 dB, so one pole are at origin. If initial slope is plus 20 dB, then 1 zeros are there. Okay, and again 1 zeros are added at omega 1, so 1 plus s by omega 1 zeros are added, and again 1 pole are added at omega 2, 1 plus s by omega 2, again 1 pole are added at omega equal to 10 पे, 1 pole are added, why, because it becomes minus 40 dB, so 1 plus s by 10. So just put here omega 1, omega 2 and k, you will get the transfer function. Okay, just let's move the next question. Same here we have to find the transfer function. So initial slope is plus 20 dB, it means 1 zeros are present at the origin. Okay, and again plus 20 becomes 0, so definitely here 1 pole are added, it means minus 20 we have to add, and 0 dB it becomes minus 42, definitely here 2 poles are there. Okay, so generalized transfer function will become k divided by initial slope is something sorry, one zeros are at the origin, okay, divided by here one pole are at omega 1, let's say omega 1, or here let's say omega 2, okay, one pole are at omega 1, so 1 plus s by omega 1, and two pole are at omega 2, 1 plus s by omega 2 whole square, okay. So it goes like this. So in this way we are, oh sorry, so in this way we are generalizing the transfer function, okay. So just find k here, okay. So initial slope is plus 20 degree, we have to use formula plus 20 into r, so only one pole are, one zeros are at origin, okay. Why? Because here plus 20 dB is given. 20 log of omega plus 20 log of k. So at omega 1, okay, or check here, at omega equal to 0.5, magnitude is 0 is given. 20 log of 0.5 plus 20 log of k. So if we will solve these then we will get k equal to 2, okay. By simplifying we will get k equal to 2. Now move the in this to find omega 1 and omega 2. So just here, or just observe here, okay. Omega, just you are moving in this way, so y2 minus y1, y2 minus y1 divided by log omega 1 minus log omega 2, y2, y2 means 12 minus y1, it means 0, magnitude you have to use in y coordinate magnitude, okay. 0 divided by log omega 1 minus log omega 2, log omega 1 minus log omega 2, it is log 0.5, and slope is plus 20 degree. And if you will solve this, then omega 1 you will get 2, okay. And just observe here, you are moving in this way, y2 minus y1, y2 is 0 and y1 is 12, okay. Omega 2 minus omega 1, log 8 minus log omega 2, omega 2 minus omega 1 equal to here minus 40 dB per decade, minus 40 dB per decade, okay. So if you will simplify these, then omega 2 you will get 4. So just put omega 1, omega 2 and k value in the generalized transfer function, then you will get the transfer function, okay. Another last but not the least question, okay. So we are just observe here, initial slope is plus 20 degree, then definitely two zeros are present at origin, plus 20, sorry, plus 40 is given. If here minus 40, if here minus 40 is given, then definitely two poles are present at origin, but here plus 40 is given, it means two zeros are present at origin, okay. So it means at plus 40 becomes plus 20, it means definitely one pole are present. So plus 20 becomes 0, so definitely one pole are present. So 0 becomes minus 20, then definitely one pole are present, okay. Why? Because just yeah, add what should be added to get plus 20. So minus 20, it means minus 20 becomes minus 20 represents one pole, so just add here, just how much you will add to become 2 cam plus 2 cam 0, so minus 20 dB, so minus 20 represents one pole, okay. So in this way, so 1 plus, it means at omega equal to 0.5, one pole are there, 1 by 0.5, okay. At omega equal to 1, one pole are there, at omega equal to 1, sorry, s by 1, and again 1 at omega equal to 5 पे one pole are there. In this way we are generalizing the formula. Main task is there, we have to find k, okay. So here initial slope is plus 40 dB, it means zeros are present, so m equal to minus 20 r log of omega, sorry, plus, why? Because zeros are present, plus 20 log of k. Okay, so just observe dear, here 2 times change, here 2 times change, it means 2 times change means 6 dB per decade, okay. So it will decreased by magnitude by 6 dB, so it becomes 20 dB, okay. So it becomes 20 dB. So magnitude, just check here, magnitude is 0.5 at 20 dB, and r is, what is the r? It means plus 20 into 2, so r is 2, okay. Or check here, r is 2. So we can find the omega equal to for by resolving this we get the omega k equal to 40. Okay, so in this way we can find the transfer function. Okay, in this way we can find the in this way. Okay, so another thing is that two questions are also left. Okay, two questions are also left. So here what is asking, so initial slope is 0, then definitely type 0 system. Initial slope is 0. Okay, so no polar present at origin, so type 0 system. So it means type 0 system we can find the steady state error. A steady state error is 1 by 1 plus kp if a step input is given. Okay, so a step input is given, so 1 by 1 plus k. Why? Because we always observe the Bode plot in the time constant form, so kp equal to k. So kp equal to k, so 20 log of, so magnitude is 20 dB, so 20 equal to 20 log of k. Why? Because initial slope is 0, so directly we use 20 equal to magnitude equal to 20 log of k, so we can find the k. Just put here, we can find the steady state error. Okay, so it is a minus 20 dB per decade. So minus 20 dB per decade represents a one pole at origin. Okay, one pole at origin means type 1 system. Okay, type 1 system. So if you for ramp input, so it will be a steady state error becomes 1 by kv, so 1 by kv becomes 1 by k. So we have so main challenge is to find k. So k equal to so initial slope is present, so m equal to minus 20 r log of omega plus 20 log of k. Initial slope is, so magnitude is 0 when at omega equal to 4 pi. At omega equal to 4 pi magnitude is 0. At omega equal to 4 pi magnitude is 0. At omega equal to 4 pi magnitude is 0. So magnitude is 0 minus 20 into r. R is, it means minus 20 dB per decade, so it means r is only one pole are present, so r is 1. So plus log of 4 plus 20 log of k, so k equal to 4. 1 by 4 equal to a steady state error becomes 1 by 4, so it means 0.25. So hope you will get it.